What's up, my fifth grade peeps? So we're going to continue working with our review and remediation of lessons to ramp us up for PMA 3 for when we get back. So we just finished on the scientific method and getting all of your experiments. So really exciting. If we need to move forward and continue that so that you're done with sixth grade, awesome. That's what I'm here for. So the next thing we're going to move into is mixtures and solutions and I'm going to bring this up real quick because we did not meet on Friday. I'm giving you guys your JJ boot camp for this week, and we will go over JJ boot camp from this week and from last week on Friday. So just be prepared. If you did not get it done, you have a whole extra week to get it done. Shout out again to Stephen Little. His mom sent me every picture of every page. So just wanted to clarify that. So here we go, moving into it. We're going to jump right in, talking about mixtures and solutions.
Hey, birthday girl.
Sam, what's up? I'm just setting up some munchies for the party.
Sweet. I brought the cake Mia and I made.
Aw, this is awesome. You guys rock.
What you got here?
Just a few mixtures of some tasty treats. Have some.
Ah, mixtures, my favorite.
How can mixtures be your favorite? That doesn't make any sense.
I don't know. I like mixing things. It doesn't always have to make sense. I'm an artist.
Sam, do you even know what it means to be a mixture?
Not really. But I'd be happy to have you enlighten me while I snack on these.
I'm sure. Mixtures are physical combinations of two or more substances that retain their properties when you mix them together. Unlike a compound, which is chemically combined, a mixture is a physical combination. That means it can be easily separated.
Yeah, I can see the different parts mixed together here. It does look easy to separate.
Well, there are two different types of mixtures. Ones you can see the different parts of, and ones you can't. This is an example of a heterogeneous mixture, because you can see the substances that have been mixed together.
Peanuts, pretzels, and chocolate chips.
We can easily pick apart the substances and make separate piles.
So, heterogeneous mixtures you can see the parts of. I see.
Now, just so you know, a mixture doesn't have to be just a solid. It can be a liquid or a gas, too. This lemonade is a mixture known as a solution. A solution's parts are blended evenly.
Is that the kind of mixture where you can't see the parts?
Yeah, a solution like lemonade is homogeneous. You can't see the sugar, lemon juice, and water that have been mixed together to make it.
Are solutions always liquids?
Nope, a solution can be a solid, liquid, or gas. It just has to have a solute and a solvent. The solute is the substance that is dissolved in the solvent. In the lemonade, sugar is the solute because it is dissolved in the solvent, water.
Well, I'm glad this solution is a liquid. It sure is the solution to my thirst.
Okay. Well, come on, make the birthday girl proud. Show me what you got.
A mixture, like this snack mix, is a physical combination of two or more substances. The substances in a mixture don't change when they're mixed, and they can be separated. We can see the different parts of the snack mix, so it's a heterogeneous mixture. A mixture isn't always a solid. It can be a gas or a liquid, like the lemonade. The lemonade is a solution, and solutions are homogeneous. You can't see their parts. Ta-da! How was that, birthday girl?
Happy birthday to me.
That's right. Now, let's get this party started.
All right. Okay, so let's jump right in here. Once again, guys, this is a review, so you should know most of it. So I'm going to go through it pretty quickly. But the things that I've assigned you to do this week, make sure you do them because that will help your independent learning. If you ever need to come back to this PowerPoint, the video, you can pause, you can look over things and get some good examples. So here we go. P8.3, so physical properties, 8.3 mixtures and dissolving. Mixtures when two or more substances are physically but not chemically combined. So looking down here at the bottom, the salad. So how can you separate the salad based on its physical properties? So in a mixture, they are not permanently combined and their properties don't change. They can be separated, which means taken apart from each other again. The change can be reversed. A new material is not formed. Sometimes it's easy to see the parts of a mixture. If you mix sand and water, shake it up, the water is going to look cloudy. But if you let it sit, the sand is going to go to the bottom and the water is going to stay on top. So you'll actually see it start to separate on its own. So mixing matters. So now at other times it's hard to see the parts, such as in lemonade. If you mix salt with water and shake it up, the salt will dissolve. So let's think of lemonade. If you take the lemon, the sugar, the water, mix it all up, now try and take out that sugar, it's going to be pretty hard, right? So dissolve means to form a solution with another substance. The substances are separated out evenly and you cannot see the separate substances in the mixture. So let's explore here. Identify and sort each of these pictures as either a mixture or a solution. We'll start over at the top left, and I just want you to say it out loud, and this will be one of the things that we go over on Wednesday when we discuss the PowerPoint. Water and sugar, mixture or solution? Right, solution. Okay, fruit salad, mixture or solution? Good, mixture. Yep, chocolate milk, mixture or solution? Great, solution. Yeah, you can't take it out. Cereal, mixture or solution? Mixture. You could pick it out. Spaghetti, mixture or solution? Definitely a mixture, right? And last one, the salt water in the ocean, mixture or solution? I'm not going to answer that one because you should know, and we're going to talk about that more. Here we go. So exit ticket 1. Kate had 2 cups of water. She added a tablespoon of sugar to 1 cup and mixed it. She put a tablespoon of sand in the 2nd cup and mixed it. What happened to the sugar and sand when Kate mixed them with water? A, the sand dissolved, forming a solution. The sugar did not dissolve. B, the sugar dissolved, forming a solution. The sand did not dissolve. C, the sand dissolved, forming a solution. The sugar evaporated. Or D, the sugar melted, the sand did not melt. What do you think the best answer is? Great, definitely B, right? The sugar dissolved, forming a solution, and we know that sand does not dissolve because if it did, we would not have the beach, right? Great job. Number 2, Juan was hungry. He put cheese, ham, tomato, and pickle on a slice of bread. He folded the bread in half and ate it. Which of the following describes what Juan made when he combined all of these ingredients? A, a mixture, B, a solution, C, a change of state, or D, a chemical change? What do you think? Yeah, A. Now, why A? Why a mixture? We'll talk about this more when we meet too, but I want you to start thinking about what is a mixture, what is a solution, and why would this be a mixture? Number 3, Joey's teacher asked him to combine several substances to make a solution. Which picture shows what Joey made? Was it A, lemonade, B, pizza, C, a box of shells, or D, a taco? Which one is a solution? So you should notice when they ask these type of questions, 3 of them are the same, 1 of them is different. Which one is different? Good, A. Yeah, A, definitely lemonade is a solution. So now we're talking about how can we separate these mixtures. You can separate by matter properties, so color and size. There are multiple tools you can use. Your hands are always a good tool, but sometimes there can be better tools than your hands. Saying if I gave you a pound of rice and a pound of rocks and I mixed them all together, right? It might be harder to go through with your hand and pick out each one. So that's where you're over here looking at a sieve. Better example, the cereal. If I pour cereal into the sieve, what's going to be caught up top and what's going to go through the holes? Good. The cereal will be caught up top and the milk will be falling through the holes. So magnets. Magnets attract matter that contain iron. Filter works like a mesh screen with tiny openings or pores, almost like a sieve or a strainer. Heat is also a good one. Boiling and evaporating is when a liquid changes it to a gas. Only the liquid particles leave and dissolved particles are left behind. Separating salt from salt water would be much difficult to do, much more difficult to do. So think about which one of these tools might you use to separate the salt from salt water. We'll talk about that on Wednesday as well. So here are your tools to separate mixtures. You have a sieve/strainer, you have magnets, you have a filter, and you have heat. So dissolving. This is talking about a solution. So that was all about a mixture. So now we're going to jump into solution. How can we speed up or slow down how a material dissolves in water? The temperature. Think about if I have a cold cup of coffee and a hot cup of coffee. Which one is my sugar going to dissolve in first? Which one has the faster moving particles in it? Cold or hot? Definitely hot, right? When things are hot, my molecules are moving faster. If you increase the temperature of the water or the coffee, right, it's moving faster because the molecules are moving faster. If I start to stir the mixture, the material will dissolve faster because the particles will connect faster with all the movement that the stirring is causing. Also surface area. So we definitely talked about the surface area and breaking it down into having that cube, right? And then we talked about having all that cube broken up into many different pieces. So having those more pieces is talking about having more surface area, which would mean that it would dissolve quicker. Try this at home too. If you have sugar cubes, take a sugar cube and put it into hot coffee, and then take a sugar cube and chunk it up a bit, hit it with something, make it into pieces and put it in. Don't stir, and see which one dissolves faster. Here's a good way to collect your data if you're going to do something like that. Remember, guys, while I'm here, remember that you can always sorry, I lost my train of thought there. You can always stop and pause the PowerPoint and get what you need and then continue to move on. Here we go. Sam made iced tea for his mom. He added sugar. The sugar was at room temperature. He stirred the iced tea until the sugar dissolved. Which property of sugar stayed the same when Sam added sugar to the iced tea? A, the taste of the sugar, B, the grains, C, the texture, or D, the temperature. So which one stayed the same? Good. A, yeah. B, the grains are going to be dissolved. C, the texture is going to be gone because it's going to be dissolved. And D, the temperature of the sugar, it's going to stay the same. I mean, it's going to change. It's going to be, just like you said, he's putting in iced tea, so my temperature is going to get colder. Number 2, which of the following lists of materials would all dissolve in water? So we know if we ever see the word sand, we know it's not going to dissolve. So we have sand in B, so we know it's not going to be B. So let's talk through the rest. A, salt, oil, chalk, flour. There's one thing that sticks out to me that I know. B, we already said no. C, salt, pepper, sugar, cooking oil. Or D, salt, sugar, instant coffee, D, hot chocolate mix. So which of these would all dissolve in water? Good. Yeah, D. Good job. D is in dog. Here we go. Last one. If your science teacher asked you to separate a mixture of sand and iron filings, which would be the best method to use? So you see that keyword iron filings. A, evaporation. B, a magnet. C, tweezers. Or D, a filter. Good. B, a magnet. If I put a magnet into sand and iron filings, my iron filings would stick to the magnet, leaving just sand. Oh, I totally fibbed you guys. Last one. Which action below would be the fastest way to dissolve a sugar cube in a cup of water? If you're doing this experiment, you definitely know the answer. We've also done this in class before. So let's think about it. I put a sugar cube in a cup of water. What would speed up that process of dissolving it quicker? A, add more water. B, let the cup sit still. C, place the cup in the refrigerator. Or D, break the sugar cube up into smaller pieces before putting it into the water. So which one would make it a faster process? Awesome. D as in dog again. Breaking it up, giving it more surface area. All right, guys, that is our quick remediation review. I'm going to share this here with you guys because I'm already here. On Monday, I'm going to download this and put this right up here so that you guys can watch the YouTube video. Here is our JJ Bootcamp pages that are going to be due on Friday. Tuesday, you have this Text Independent. It is literally a book you're going to scroll through. I think there are 7 questions. Answer those 7 questions. Post it on message board, write it on a piece of paper, and take a picture. Either way is fine. Wednesday, we will meet. We're going to talk about the PowerPoint, talk about our exit tickets on there, and then I'm going to assign you your activity that's due on Friday. That activity is right here on Thursday, and this will be posted up if you want to start on it on Monday. That's fine. So what I'm going to have you do is draw and explain a mixture and a solution. Give me an example of both and how you would sort them back to their original state, if you can. I want you to upload and send this to me by Friday, and I will definitely be sharing some to my page. Friday, we're going to meet at our normal time, 9 a.m. We will go over JJ Bootcamp from last week and this week. So if you're on task, if you're paying attention, if you watch, you're good to go. That's all I got for you guys. We're moving through. I'm getting you through this review and remediation. If you guys get bored, jump on the study jams, do some mixtures and solutions. Other than that, I'll see y'all on Wednesday. Much love. Have a wonderful day.